want to find what is ln of 1 plus x, 1 minus x. Okay, the series expansion for this. So what we do is just we put ln of 1 plus x minus ln of 1 minus x. Then we just quote the result from the above. Okay, just quote that, you get the series expansion. So much takes time. Okay, so you get, let's say for example, in this case it becomes 1 ln of, so you get 1 plus x is x minus x squared on 2 plus x cubed on 3 minus x to the 4 on 4 and so on, and then minus x, so minus minus, so you get plus, you get x plus x squared on 2 plus x cubed on 3 plus x to the 4 on 4 plus so on, because it's minus minus, you see. So you get, in this case you get 2x plus 2x cubed, x cubed on 3 plus 2x to the 5 on 5 plus 2x to the 7 on 7 and so on. Okay, so let's say we have example 2. Example 2, let's say we want to find what is let's say e to the 2x plus e to the minus 2x divided by e to the x. Okay, so you want to find this thing. So we get, expand this thing lah. So we get, we are going to get e to the x, e to the x plus e to the minus 3x, isn't it? This one and that, okay. Alright, so you have this thing, then you just put in the value. So e to the x is equals to 1 plus x squared on 2 factorial plus x cubed on 3 factorial plus dot dot dot, okay, and then plus e to the minus 3x. So you get 1 minus 3x plus minus 3x on 2, squared on 2 factorial plus minus 3x cubed on 3 factorial plus dot 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 dot, and then solve it. Okay, so now what about the range of validity? The same thing now. Range of validity is because this is exponential. The range like x belongs to real, so the same thing lah with this. Okay, just now I forgot to mention about the when you have that, what is the range of validity? This one, example 1. For this, the range, you have to combine the range of validity. Range of validity for this is what? Because you cannot have ln of 0, so you cannot have minus 1 for this one. So for this, you have x is bigger than minus 1, less than 1. For this one is bigger or equal to minus 1 and less than 1. So the thing, in this case, x, combine the two, so you get minus 1 and 1. This is the range of validity. Get what I mean or not? In this case, this one cannot put in this. That is the range of validity for the first series, and then for the second series, this is the range of validity. So you combine these two. Okay, for that one is okay, and then let's find let's say we try something different. Okay, oops. Let's say this is an example. You get ln of 1 minus 2x divided by 1 plus 2x squared. So this thing will become, simplify this first, you get ln of 1 minus 2x it has to be less than half, bigger than if you have minus, can, right?
Bigger than 0.
Zero ka? For the first one.
We have
If you have this one less than half
hyperbolic
and bigger than or equal to
hyperbolic function,
minus half.
we have like sin x,
Okay.
Oh, okay.
cos x,
because the basically you know you
times
get the series
x.
expansion.
This one the basic, yeah.
Expansion is
So
going to be
if we
the power
get the
increasing
standard
power of
result,
2x kan.
Mm.
So by right in
okay, if this is y equals to f of x,
standard
this is
is going
dy
to be 2x
by
is less than 1 when you get a series expansion of increasing power of 2x. So that would be the range of validity.
Oh.
But so in this case it's going to be less than or equal to. So you get, in this case, x must be greater than or equals to half, negative half and half kan. So but in this case you cannot have half, because when you put half here, not equality, because when you put half here you get 1 minus
0,
1.
1.
1 minus 1. So 1 minus 1 is 0.
Yes.
You cannot have ln of 0. So that's why you exclude the equality. So for this one, the same thing lah. So you have you cannot have half minus half here.
Yes.
Because when you put minus half, you get 1 minus 1. So for this, the range of validity for that is this. Range of validity for this is going to be x minus half. Oops. Less than half. So if you combine the two, you get x. Combine the two lah. Okay.
Yes.
All right. Now, let's say if you have something, let's say, if you have, that you have to expand lah. Let's say you have something like that lah. E to the x, and then ln of 1 plus x. Expand up to x to the power of expand up to x cubed, for example. So when you have something like this, what you do is you get series expansion of e, and then multiply with series expansion of ln 1 plus x. And add lah. Okay, so you get, let's say in this case, what is the series expansion for e? You get, what is the series expansion for e? So 1 is 1. So 1 plus, oops, y. One plus, what is series expansion for e? Yeah? 1 plus x plus x squared on 2 factorial plus x cubed on 3 factorial. Because I'm asking for up to x to the power of 3. So I just take up to x to the power of 3 lah. And then series expansion for ln, I have x minus x squared on 2 factorial plus x cubed on 3 factorial. Oops, sorry. Mana boleh this one without kan? Yes, on 3 minus x to the 4 on 4. Okay, so then we have, you expand lah, so you get the x, there's no constant, so just x, so x and then plus x squared, you get x squared, this multiply with that, so you get 1, and x squared minus 1 on 2. And then the next one is like x cubed. X cubed, you get this multiply with that, which is 1 on 2 factorial. X cubed, nothing lah. So x, this x squared on 2 factorial plus 1 on 2 factorial also. Plus nothing. The next will be x to the power of 4, so we don't have that. So it will be x plus x squared on 2 and then plus x cubed. So this is up to x to the power of 3. So whenever you can simplify it, simplify it. Whenever you cannot, then you just expand, divide it into series lah, and then multiply both series expansion. Okay, let's say I have let's say sine, example 4. Let's say you have sine of a plus x. Okay, a is a constant lah. So if you have this, what you do is you do it like the you get the expansion of this. So you get sine a cos x plus sine x cos a. So then you get sine a and then get the series expansion of cos, which is series expansion of cos is 1 minus x squared onto factorial plus x to the 4 on 4 factorial. Of course, normally they would specify, okay, not normally, they have to specify until what degrees power of x that you have to expand, or sometimes they ask you to just expand it up to the first few terms, first few non-zero terms. Okay, so this one plus, you have cos a, and then sine x is equals to x minus x cubed on 3 factorial plus x to the 5 on 5 factorial. Okay, and then you get, let's say you want to find the first 3 non-zero terms. So you get x, x, sorry, not x lah. The first, this one has got, one of it has got sine there. So the constant is like sine a, and then plus x. Plus x will be cos a, and then plus x squared. So I have sine minus sine a onto factorial. Okay, that is the first 3 non-zero terms. You have the constant term, you have the x power 1 and x power 2. So it depends lah. If the question asks you to find up to x to the power of 5, then just expand it. You just make sure that here you expand it up to x to the 5. But of course here you have like x to the power of 6, yeah? So that one is not included. So if the question asks you to find up to x to the power of 6, then you have to have that one as well. Okay. Any question? I give you some that involve hyperbolic. Yeah. Sometimes you have, let's say, okay, let's say hyperbolic lah. Okay, expand cos x. Cos x up to as a series of ascending power of x up to and including in terms of x to the power of 6. Okay, so you have cos x is equal to 1 on 2 e to the x plus e to the minus x, right? So you have, in this case, you expand it at the normal one, expand e to the x, find e to the x, and find e to the minus x. Let's say we want to find something else lah. Let's say sine to x, sine squared x, sine squared x, example 5, example 6. Okay, sine to the power of sine squared x. This is equal to, if I take I want to reduce it into something that I can quote the standard result. So you have sine, we want to find this, so you get like 1 minus 2 sine squared x is equal to cos 2x, right? So we have sine squared x is equal to 1 minus cos 2x divided by 2. So you get, in this case, you get 1 on 2, 1 minus the series expansion of cos 2x. Like that only. Okay, so you get lah half minus series expansion of cos 2x. Series expansion of cos x is equal to so for cos 2x is going to be 1 minus 2x on 2 factorial squared. And then you have plus 2x to the power of 4 on 4 factorial. And then minus 2x to the power of 6 on 6 factorial. Okay, if I ask you to expand up to x to the power of 6. Okay, up to x to the power of 6. So you have lah. Expand this, so you get half minus half, 0. And then this one is like 4x, so you get 2x. And then here to the power of 4, 16, 16 divided by 24. Sorry, 16 divided by 48. 1 on 3. Isn't it? 4, 16. 16 divided by 48. Minus and then that one to the power of 5, 32, 32, 64, 64 divided by 6 factorial. 6 factorial, 6 factorial, 2 times 6 factorial. Okay. So that's, anybody has any question? This is just to use the standard result. Okay, you won't be asked to like derive that, yeah. But you can you might be asked, you might be tested on how you can use the standard result of this McLaurin series. Okay, let's say I have one question here that involves okay, example 7. If y is equal to tangent to the minus 1 of x, prove that 1 minus x squared d squared y by dx squared, this one is second derivative, yeah? Minus 2x dy by dx is equals to 0. Find the series expansion of, then hence or otherwise. Find series expansion of tangent to the minus 1 of x. First 3 non-zero terms lah. Alright, so how do you do this? Okay, solution. Y is equal to tangent to the minus 1 of x. Y is equal to half ln 1 plus x, is it? 1 minus x, is it right? Is that right? Guessing.
Should be.
Yes.
Okay, alright. So what we do is like you get dy by dx. Alright, y is equal to, make things easy. So whenever you see ln, you have functions like this. You to make things easier, you get simplify it, yeah. So half ln 1 plus x, and then plus minus ln 1 minus x. Okay, so you differentiate dy by dx is equal to half 1 plus x minus half 1 divided by 1 minus x times minus 1. So plus lah. So it becomes 1 on 2, 1 minus x, put it under common denominator, plus 1 plus x divided by 1 minus x squared. Okay, so you have dy by dx is equal to, cancel, so 2 cancel with that, so you get dy by dx is equal to 1 divided by 1 minus x squared. Okay, so you get 1 minus x squared dy by dx is equal to 1. Okay, then differentiate another time. So you get d by dx of 1 minus x squared dy by dx is equal to d by dx because it's 0 lah. Okay, so differentiate x. This one is a product of two functions. So differentiate this, you get minus 2x dy by dx. And then keep 1 minus x squared and differentiate that, you get d squared y by dx squared. That is equal to 0. So you get 1 minus x squared dy by dx squared, d squared y by dx squared minus 2x dy by dx. Okay, it's equal to 0. Okay, correct. So now you prove. Okay, alright. So find, after that, find the series expansion of this. Okay, dy by dx is equal to, this one is like f prime of x. Okay, they're a bit messy here, I guess. So what is f prime of 0? What is f prime of 0? 1 lah, isn't it?
Yeah.
Okay. F double prime of 0 is equal to, f double prime of 0. So because this one is going to be, because you multiply with x, x is 0. So you get 0 lah. So from here,
you differentiate another time. So from here you differentiate another time, you get 1 minus x squared d squared y by dx, d cube y by dx cube, plus you get minus 2x, and you get d squared y by dx squared, and then plus or minus 2x 2 dy by dx, and then minus 2x d squared y by dx squared, that is equals to 0. So you want to find dx cube y, isn't it? So that one is 0. This thing is 1. That one is 0. So, but d cube y by dx cube, when you put in x is equals to 0, you get 1. So you get d cube y by dx cube is equals to 2. Is that right? Because that one is 0. This one will be 0. So that one is 1. So minus 2. So bring it onto the other side. This one is 1. So d is equals to 2. Alright. So you get that? Sure, 2. Okay, namalah. Then you get, you want to find the next one. I asked just now up to what? 3 non-zero terms. Now we only get 2. Next one sure 0 punya. So you get differentiate another time. Differentiate this, you get 1 minus, you differentiate another time, you get d to the d power 4, and then you get d power 5. Yeah, so d power 4, you get 1 minus 1 minus x squared d to the power of 4 y dx to the power of 4 plus minus 2x d cube y dx cube, and then plus minus 2x d cube y dx cube. Oops, tadi minus 4 ya. So I get 4 lah, minus 4. And then plus minus 4, differentiate x, you get d squared y. Oops, d squared y by dx squared, and then I have minus 2 d squared y by dx squared. Okay, that is equals to 0. So you put in this thing, put in that, because d at x equals to 0. Sorry, this one is like f cube 0 is equals to 2. So you put in this value, oops, equals to 2, and then you put also this one, put in this one, put in that one, then you will get what is this thing. And then differentiate another time, you get differentiate another time to get, so you get cube, you get to the power of 5 lah, in the power of 5. What is this thing? So you put in this. I think this one is going to be 0. Okay? So basically, this is something that you might be asked. All right. And then what else? Okay, any question?
No, Konju.
Yeah, actually, now we have there are times you you are also expected to be able to recognize the series expansion, the standard series expansion. So it's like if you see pattern, if you see pattern, so you reduce it, then you can guess. Let's say for example, you get macam, let's say if you get e to the x, you get something like this 1, and then you get 2x, and then you get plus 2x, and then you get plus let's say you get 2x squared, and then you get let's say this one 2 8 8, let's say you get 4x cube on, let's say sorry on 3, for example, something like this. So you know that in this case, you know that this is 1 plus 2x plus 2x squared on 2 factorial. Or you have e. Wait, e is what? Let's say you get this one is on 2 factorial, and then this one is like 2x cube on 3 factorial. Okay, so you know that this is actually e to the 2x. You are expected to be able to detect all this, so maybe they give you some kind of hint before that, show this something because of something, and then you get they give you a series expansion, and you should be able to recognize that, yeah, because this is for the math, so it's not like it's not straightforward. There are things that you are expected to be able to detect. What else? That day, I give you anything on differentiation of parametric equation or not? Second derivative of parametric equation?
Don't think so.
Why so tak semangat?
Tomorrow, Konju.
Tomorrow results day.
Konju, do
I
you see
pray for you.
do you see our message in the group chat?
Tak tengok pun. Okay. It will be 3 o'clock tomorrow, right?
Yes. 1 to 3 o'clock.
1 to 3, okay. Don't worry, insyaAllah. Kan, they said that it's going to be like 39% brought down.
Yes.
So let's hope that you are all in that 61% lah.
InsyaAllah. Amin.
Yeah. Tak ada, no, not to worry lah, because they are not going to penalize you if you. But it's just that the thing is, if you don't get the grades that you want, then you will have to sit for it. Kan, it's not nice.
Yes.
It's not fair. It's not fair because they shouldn't be making you sit for it unless you have like the result is really poor, kan? Because it's not you who doesn't want to sit for the exam, isn't it? So,
Betul.
but anyway,
Betul tu.
lah, okay lah. Basically, differentiation of parametric equation, second derivative of. Okay, parametric equations. We consider parametric equations. Let's say we have like x is equal to f of t, and then you have y is equal to g of t, and then our of course our dy by dx is going to be dy by dt divided by dx by dt, which is actually equals to g prime f prime of t. Okay, now this is the first derivative. Okay, the second derivative, get d squared y by dx squared is equal to oops. Is equals to d by dx of dy by dx. Okay, so this is equal to d by dx of our
Panju, you showed before.
itulah. Okay lah.
Panju.
Okay.
Sorry, I thought you didn't. Sorry.
I also tak ada mood sebenarnya. Maybe I give you, okay, next week I give you another test, boleh? Can or not?
On what, Panju?
Test.
This hyperbolic plus second derivative plus McLaurin series. I give you two questions lah, easy, but so put it this way lah, the function is going to be
Tedious.
no, function is maybe hyperbolic, okay, and then you have also parametric equation, and then you have implicit. Okay, I give you two short question, two long question. Double period.
Monday or Wednesday, Panju?
Wednesday.
Okay.
Panju, tomorrow, right?
Uh-huh.
Can we have the class off or not?
Boleh.
Thank you, Panju.
Alright. Sebab we take attendance as well.
Alright, thank you, Panju.
Okay. Alright. Okay, anything else you want to ask me now?
Wanju, can you repeat the scope of the test again?
Got all the tests. Okay, the test. Okay, I put it this. Test next week. Next week, Wednesday. So we have hyperbolic, calculus, yeah? Okay, and then we have second derivative. Could be second derivative, second to second derivative, which is third derivative, and so on lah. And then McLaurin, because like I mean you learn second derivative and then you learn third derivative, fourth derivative, you know. So this one is McLaurin. Okay, I think I give you 3 questions lah. Oops. Okay. All right. Hyperbolic calculus. So you have differentiation, you have integration. Okay.
Alright, guys.
Okay, I let you off now. I'll take attendance first. Oops. Mana kita punya ni? Okay, see all. Okay. Anything else? Tak ada, otherwise you just call it off for now.
Alright, thank you, Bonjour.
Thank you, Bonjour.
Okay.
Thank you,
Bye.
Bonjour.
Thank you,
Alright.
Thank you, Anju.
Okay, bye. Start for tomorrow.
Thank you. Thank you, Bonjour. Thank you,
Alright. Okay. Inshallah, pray for you. Okay. Alright. Okay, bye.